Hello everyone, this is Vishali Pawar. Today I am here to explain the experiment number 2, that is application of op-amp as an adder and as a subtractor for a DLIC subject. The simulation tool which I use here is the ORCAD. So let us understand the experiment. The experiment has three parts. First is to implement a linear equation using op-amp. Second is to design a non-inverting adder to add 3 DC input voltages, and the last is to design a subtractor. So first I will show you the theoretical calculation of this, then we will do in the simulation. So first is to implement a linear equation using op-amp for a VO is equals to 2VA plus 3VB minus 4VC. Step 1 is the VO1 is equals to minus RF by R1 into VA plus RF by R2 into VB. So by solving this we get the R1 is equals to 10K by 2, that is 5K. Standard value which I choose here for resistor R1 is 2.7K, 2.2K, 100 ohm. So plus sign indicates that I will be using this in a series. So same for the R2, and the step 2 is VO2 is equals to minus RF by R3 into VC is equals to minus 4VC. By solving this we get the R3 is equals to 10K by 4 is equals to 2.5K. The standard value which I choose for R3 is this. So finally we get at step 3 we get the VO is equals to 2VA plus 3VB minus 4VC. So we are taking two op-amps IC741. First we will give the VA and VB input at the inverting terminal, and that output we will feed as an input to the second IC at the inverting terminal. So it is also where we also adding the VC input. At the output we get the VO is equals to 2VA plus 3VB minus 4VC. So second is to design a non-inverting adder to add 3 DC input voltages. Here is the diagram for that. 3 input voltages are VA, VB, VC at a non-inverting terminal. So analysis of this is the applying superposition theorem at a voltage V1. Here is the voltage V1 at a non-inverting terminal. So let us take all resistor values are equal. For a non-inverting configuration with the only VA input, we get the V1 dash is equals to this and is equals to VA by 3. Only VB, V1 double dash is equals to this and VB by 3. Only VC, V1 triple dash is equals to R2 R combination, and we get the VC by 3. By adding all three, V1 is equals to V1 dash plus V1 double dash plus V1 triple dash, we get the V1 is equals to VA plus VB plus VC by 3. So VO is equals to 1 plus RF by R1 into VA plus VB plus VC by 3, equation 1. If the gain 1 plus RF by R1 is equal to the number of inputs, then the output voltage becomes equal to the sum of all the input voltages. So here we are taking 3 inputs, so this is equals to 3, and by solving this we get the VO is equals to 1 plus 2 VA plus VB plus VC by 3. At the final output we get the VO is equals to VA plus VB plus VC. So basically this non-inverting adder will add the input voltages and give the output total. Next is to design a subtractor and implement a linear equation. So basically subtractor diagram is this. So basically differential amplifier can be used as a subtractor shown in the figure. Analysis of this is the let us take all resistor values are equal. So the gain is 1 using superposition theorem in order to get the output. So if VB is equals to 0, it is becomes the inverting amplifier configuration, and we get the VOA is equals to minus RF by R1 into VA. And if the VA is equals to 0, then the configuration becomes non-inverting amplifier. So V1 is equals to minus R3 by R2 plus R3 into VB. So VOB we get is this. So therefore all the resistors are equal. So we get the VOA is equals to minus VA and VOB is equals to minus VB. So at the output we get the VO is equals to VB by VB minus VA. So the circuit is called subtractor. By looking at the equation, it is basically subtracting one input to the another input. Let us execute this into the software. So go to the ORCAD software, go to the file, go to the new and project. Name whatever you want. I am giving name here is the subtractor, and make sure that you select the PSPACE analog or a mix A to D. Location whatever you want, click on OK. Make sure that you create a blank project, click on that and click on OK. So window will appears. We need a components to our circuit, so we go to the place and select the parts. For our parts we would also choose this icon for a shortcut key. So we need a IC741. So type LM741 So double click on at that and place wherever you want. Make sure that you end the mode. Second, we need the resistors. So let us R and R analog, place one here, one here, one here and one here. Feedback resistor. End mode. We need a VDC supply to give the input as well as for the op-amp. So type VDC, choose this, one here, one here, one here. So end mode. Arrange this in a properly manner. Make sure your op-amp is mirror vertically. So now inverting terminal goes upper and non-inverting goes lower. So arrange this in a proper manner near this near this supply is near this and this supply is near this, and this, make sure you rotate this using a R key. So goes here and this is also rotate if you want. If you do not this rotate and near this and feedback resistor near this. We need a wire to connect our circuit. Go to here, select a wire and connect our circuit here to here and here to here. Make sure that you connect a circuit properly. If you do not connect a circuit properly, we get an error. So make sure that here to here, here to our output pin and VEE and here to here. Here to here and here to here. To this supply. So add mode. So we need a ground supply. Go to here, place ground, click on that, click on OK, place ground here, one here, one here, one here and one is here. End mode. So our circuit is completed. We gives the value to the component. Here I am giving the 1 volt VDC. You gave whatever you want. I am giving here is 5 volt VDC. Make sure that you take the resistor values are equal. So next is the, here is the minus 15 VDC and here is the 15 VDC which op-amp needs. So our circuit is completed. Go to PSpice, new simulation, type simulation name, whatever you want. So create, the window will be appears. Do not make any changes, just apply that to run the circuit. So run this. Here is the voltage display, here is the current display and here is the power display. We need a voltage display. So you can see here we will giving the 1 volt VDC at a non-inverting terminal, 5 volt VDC. So 5 minus 1 we get the 4. So it will basically subtract the one input from the another input and give the output. I also done for the linear equation, that is VO is equals to 2VA plus 3VB minus 4VC. I am taking the input as 1 volt VDC, 1 volt VDC and 1 volt VDC. When we are substituting this, in this we get the 2 plus 3 minus 4. So we get output. So run that and click here. We get the output is 1, that is 5 minus 4 is 1. So I also done for the non-inverting adder. We can see that also. Here is the non-inverting adder. I'll be giving the 2 volt VDC, 3 volt VDC and 4 volt VDC. So let us see what happens at the output. Run this and click here. So we can see here 2 plus 3 plus 4 is the 9 at the output. You check for another inputs also. So I will show you another inputs. Here I have done for the another input also, and make sure you first calculate theoretically and then you will observe the practically. Here I also done for this. Here is I giving the VA is equals to 2V, VB is equals to 1 volt and VC is equals to 2. I'll get the output as minus 1V. Also done for this. And here is the non-inverting adder. You can choose whichever inputs you want and check for that. Here also I will done for this and get the output, also for this and get the output. Here also I done for the subtractor for different inputs. You can give whatever you want and check the output. I done this for this for this. So the conclusion is the application of this is the audio mixer and Wheatstone bridge differential amplifier or a subtractor. So like this I performed the experiment 2 successfully. Thank you.